कहीं से बैकग्राउंड साउंड आ रही है, म्यूट करो।
It's from me.
I think we are live, ma'am. I think, yeah.
Yeah. So, guys, we are live, and after checking all our settings and systems, whether we are on mute or our system audio is working fine or not, again, we are here to talk about today domain 3. And in our last two sessions, we really had a good conversational session with Manoj sir, and he was really very kind to talk about domain 1 as well as domain 2. So, this domain 3 today we have divided into a few series. This is the sub series of domain 3, and it talks about security architecture over here. So, sir, we really had a great fun. So, before I start with this morning chit chat sort of a session, let me introduce you. So, I am so glad to introduce Manoj Sharma, sir. He is the cybersecurity expert, and he's been guiding all the aspirants in cybersecurity, not only in CISSP, in other various other certifications like CSAM, PCI, DSS, and people have really got benefited. They have applied this knowledge in their day-to-day office activities and all. And I'm sure, guys, you are going to like and love the session the way you liked the other two sessions. And we really got very good feedbacks on the sessions. And today I'm so much motivated again to carry on with this masterclass, CISSP Success Toolkit Masterclass with Manoj sir. And this is our domain 3. Here we will talk about the security architecture and many other stuff which is still lined up. So you already know him. He is the expert, cybersecurity expert, and he has served Indian Navy. He is a military veteran as well as various many
Ma'am,
other
every time, sometimes you say I was from Indian Army, sometimes you say I am from Navy. I am actually from Indian Air Force.
Yeah,
Okay, sorry
I'm so
about
sorry.
that.
I get so much excited to introduce you, so I forget about it.
Yeah,
Serving the
okay.
nation is the main thing, whether it is a army or it
Yeah,
is air.
very true, ma'am.
Yeah.
Being in defense forces, it's a lot of matter of proud, right, for everyone. So,
Yes, yes, yes. And again, adding on more, now you are the professor of practice in one of the renowned university in Bangalore. Many congratulations for that too. And
thank
let's
you.
move on ahead. Today we'll be talking about domain 3, which covers around 13% of weightage is there for domain 3 in our CISSP exam. So before setting it, let's talk about the agenda. What we'll be doing here for 1 hour over here. We'll be talking about domain 3, how to prepare for that domain in a very strategic manner. What are the objectives which we are going to cover here? What type of questions are asked based on domain 3, and how to prepare effectively with a proper mindset for domain 3. So moving ahead, sir, please throw some light again on how to go for the CI. What has to be the CISSP mindset for the candidates or aspirants who are really looking for the CISSP goal? And please
Okay,
go ahead,
great,
sir.
great,
Thank you.
ma'am. Yeah, yeah. So, I think, guys, this is the touch point where we are starting with every session with the mindset for CISSP has to be very different. I know you guys are already experienced. You guys have good experience in security, and even then, it's not just about the experience which matters in the exam. It is more about your mindset, I would say, and you should also be having a good understanding on how to answer the questions as well. So as you can see on the screen, I see some video issue, but you can see two parts here. One is your prep and another side is your CISSP exam. So the moral of the story which I want to tell you guys here is very simple. Just preparing and going through some training or going through some kind of content is not enough to pass the CISSP exam, because CISSP exam is going to test you on different kind of scenarios, real world messy situations and all of it. And for that, it is very important that you are understanding those scenarios and the kind of challenges which comes in, and you master the art of answering a CISSP question. Exactly the same thing we do when I practice with you live for 60 plus hours, and I make you ready for the CISSP exam, how to understand these kind of questions, how to comprehend, and all of it. Anyways, I think that's the mindset altogether. This entire series is focused on the same. Let's go ahead with the domain number three.
Yes, so today's topic is security architecture and engineering. Many of the candidates they really find it quite challenging how to prepare for this because it covers a huge objectives and they are quite technical too. So the first objective which we are focusing over here is based on the research how to implement and manage the engineering processes during secure design principles. So, how the candidate should go ahead and understand these concepts and what type of questions do they expect from this objective?
Okay, great, ma'am, great. But I think before that, I'm sensing a little bit of background noise. So I think, ma'am, once you're not on talking, I think
Yeah,
you can go on. I think there's a little bit of subtle,
all right.
some kind of background noise. Okay, I think now is perfect. Okay. So before we even dive into the objective number 3.1, we need to understand the entire mindset of domain number three, right? And in domain number three, you are going to play a role of somebody who is a security architect. So when a particular software or hardware or something like getting prepared by the company, they are preparing a system. Now what is a system? A system is something which takes an input, process it, and give you an output, right? So when it is happening, security team is always has to be integrated into the entire process, even from the planning phase by itself. If CISSP is asking you that, you has always, like, security has to be part of each and every process, I would say, from the very beginning. So that is the first fundamental thing which you need to understand. Second thing is, this entire domain also sets you not just from understanding some security basic principles. It also talks about a lot of different type of information systems which we have, and how do you need to take that, how you need to integrate security into that. So all those kind of things uh, you know are part of this particular domain. Many people, they feel very overwhelmed with this domain because this is little bit technical here, but as we go along objective by objective, I will give you more insights, right? So now I'm coming on the objective number 3.1. It talks about research, implement, and manage engineering processes using secure design principles. So this is the foundation for the entire domain number three, and it talks about 13 different security principles. The first one of them is the least privilege, and we all know people should not be given more privilege than required. We already have something called as need to know. People should not be given access if they don't need to have access in the first place. So always, please understand from the exam perspective also, need to know will come first. Need to know will help you to prevent confidentiality, and least privilege will help you to maintain the integrity of the system, which will least privilege will always come after the need to know. The basic purpose for both of them, need to know and least privilege, is to make sure that you have proper segregation of duties, and segregation of duties is there to prevent the frauds. I think that is a fundamental touch point you need to understand from the exam perspective. Now, second thing, it also talks about defense in depth. So when we talk about defense in depth, that means you don't have to rely on one single control when you are architecturing a system. You have to inbuild different type of systems. It can be preventive, it can be deterrent control, and then it can be detective controls and response control. You have to have a series of controls put up so that if one control is failing, at least the another one will work. So always, whenever you are architecting systems, always focus on defense in depth. The third one is, the main principle here is fail securely or fail closed. So fail securely means if you are implementing a system, a security solution, you have to always go with fail security, because your primary objective is to take care of the security part. Yes, in some cases where business is taking precedence, that is where we go with fail open or fail safe for people security and all of it. But when it comes to matter to security, we are going with fail security. That means if the particular system fails, it should not allow the bypass of the controls. And yes, bypassing a particular control is a big threat, but at the same time it can also hinder your business as well. So that is where your resiliency comes into place, and you need to have failover mechanism and all of it. So I think that is one of the important principle. Then this objective also talks about something called as trust but verify. And trust but verify is a principle which is, it has served the world for decades. And it means that when somebody is coming to your organization, let's say an employee is, or let's say an administrator is coming to your company, then we give them a default level of access. Few of the services they will be able to access without any problems, like they are trusted. But for anything more sensitive, there is a level of authentication which has to happen. This is the principle called as trust but verify. It has served the industry for over like 2 to 3 decades. But now with all AI systems coming in, the threat getting more, you can say, more intelligent, attacks are happening. That is where we are going with something called as zero trust. And zero trust is a inside out approach. Okay, now what is this inside out approach? Inside out is means the internal employee or internal trusted component of a particular system can also be a threat to you. Whereas in trust but verify, our approach was outside in. We were always thinking that the threat is always residing outside the company, and then sometimes it will come and attack us, right? So I think you need to understand this subtle difference, because these fine line differences is what is tested in the CISSP exam. Then the next principle which is tested, architecture principle which is tested, is something called as privacy by default. And privacy by default means you have to integrate security and privacy from the very start of a system design and architecture and all of it. Okay, so that is where you need to bring in privacy as well. Then next one is secure default. And secure default means, let's say you are making a software and you are going to then roll it out into the production. Obviously there are some security configuration settings. You need to make sure those settings are keeping the system secure. It may not be the highest level of security, but at least a minimum level of security is what you have to put up by default. Reason being, because many people, when they start using the system, they don't even tweak any setting. How many of you have configured your Gmail setting when you started using it? Nobody, right? Very, very less people. So by default itself, the system has to be configured in a default state, a secure state. Then I think most fundamental, separation of duties. I would say, guys, separation of duties, at least you are going to get two questions in the exam for sure. It is one of the most fundamental principle here. And separation of duties says that if there is a critical process, you don't have to give anybody end-to-end access to the entire process. Break it down into multiple parts, give access to different people or different teams, or even sometimes different companies as well. And that is how you can see separation of duties is one of the fundamental principle, not only for technology, it is also for people and process as well. And it is fundamental thing in all the frameworks. Okay. The next thing they also talk about is encapsulation, right? And encapsulation means those things which are very tricky, which are very secret to a particular system architecture. You shouldn't describe all and everything in the code. Rather than you encapsulate them and then make it like in form of some libraries or something and restrict the access and all of it. So that is also one of the fundamental principle. Then another thing is, if a system has to be efficient to operate, it is also important that the system is redundant as well, because you want to make sure that resiliency is always there. If something is breaking down or something bad happening, at least the entire system is not down. So you focus on high availability and those kind of things, backup processes and all of that. So that is what is called as your redundancy. And Whenever you are architecting the system, the next principle here is attack surface minimization. You have to configure your system, you have to design your system so that by default the attack surface of the particular thing is kind of controlled. Now some of you might feel, sir, what is this exposure or attack surface? It is the total sum of exposure of a system to the threats. So you have to try to minimize the exposure of the system to the threat, and that comes through implementing preventive controls and all of it. Okay, finally, this entire section also talks about threat modeling, and that is fundamental to this entire domain, because whenever we are doing architecturing and engineering, by the way, if you are still confused what is the difference between this architecture and engineer and how we are using differently, so architecture is all about designing, and engineering is implementing that design into your production. Like, end of the day, that is your goal, right? Move a secure system to the production. So in this entire process, whenever the design is there, you have to review the design. The security team has to review the design through a threat modeling process. It is nothing but kind of a sort of a risk assessment itself, but it is done proactively on the system, and it is done to identify any kind of threats thing. We also have some kind of attack trees and all of that configured to do the proper threat modeling, and that is where you try to anticipate any kind of threat which might hit you, and then you implement the appropriate control. So this is a very proactive approach. So these are the 13 main principles which are there. I would like to emphasize especially on two ones out of it. Number one is zero trust. That is quite testable, and you need to understand that zero trust is not only a technical thing, it is also, I would say, people, process, technology kind of thing. So don't think that zero trust is a product or it is a technology. It is the entire approach. By micro segmentation, you are giving people granular access, you are trying to do more and more authentications all the time, like you trust nobody. Sometimes in a zero trust, the micro segmentation is even to a single system as well. So that is what is zero trust. Important to understand from the exam perspective. And then the next one is privacy by design. So when we say privacy by design, it is that you need to integrate privacy controls into your design, because obviously you are going to roll it out for your customers. A lot of privacy regulations coming up, and very, very important to secure the data from the personal perspective. For example, if you are collecting data, make sure that you are putting notifications, you are taking consent from the user, you give access to the privacy policy, all of it. So I think that is what this entire objective talks about. A lot inside, but very, very simple. There are 13 security objectives, or you can say principles, which you need to know. So that is all about objective number 3.1, ma'am. Are you on mute, ma'am?
Yes, I was in mute because maybe some background noise from my laptop. It's okay. So, guys, I hope you understood about all these 13 principles which Sir has explained to you, and keeping in mind the two main important one, the zero trust, and the second one, which Sir has explained over here. So, if you have any questions, your comments are most welcome. You can comment below, and we'll just catch up with those questions at the end. We'll try to cover up those. So let's move on ahead with objective number 3.2, which talks about understand the fundamental concepts of security models. So, sir, please throw some light on this too. I'm sure people are really very curious to understand and get a good insight about these sub objectives also,
Yeah, yeah,
including the.
and yeah, I
Yes.
would say, ma'am, I would say this is one of the hardest part of the entire domain too, because many people, they think this objective more from a you can say theoretical perspective, because they are not able to relate this to the practical world. But believe me, guys, this is all very, very practical. That is how I make people understand all this. So let me go through objective by objective, right? So the objective number 3.2.1, it says fundamental of security models. Now when we say fundamental of security models, means you need to understand what exactly is a security model, right? Let me give you an example. Flying an aircraft is a very complex thing, isn't it? Aircraft is a very, very complex machine. But let's say you want to test it out how aerodynamic works on an aircraft structure. Are you going to put an entire aircraft into the testing mode? Not possible, right? And very costly affair. So what we normally do, we make a very, very simple model of the aircraft, replicating the main thing, and then we try to test it on. Similarly, what has happened is in security as well, any kind of model which is based on security is called as a security model. And in security model, we are trying to put forward an architecture of a particular system. And when we put a architecture of a particular system, now here I will jump to objective number 3.2.2. It says multi-level systems and challenges. A little bit insight here. You know what? Have you, like older people, all of you might be very much aware about the disk operating system. You used to put a 5.5-inch floppy, and then a black screen used to come. You start typing all of it. You cannot hear two songs. You cannot do anything in parallel. Only one thing at a work, and also one person on the system at a point in time. I think all of you are able to relate. Now we are living in a era where we have multi-level systems. That means a system can have multiple users, number one, and those particular users can be from multiple levels. They may have multiple level of access. Some might be normal users, some might be power users, some might be administrators, and so on. Okay, so when we are using a system by different people with different privilege level, how do we control the access? So all the security models which are here, they are focused on the access control. How do we make sure when multiple people access the same system, we control their access? So that is where all the security model concept actually works in. And then I'm diving in on 3.2.3 that's talked about the security model. Now, many people out of you will feel, man, I'm back to my engineering days. Right? Because that is how it looks like. Actually, not. It is very, very simple to understand. You don't have to do a PhD into this. Just understand that there are some security models. Now, for a better understanding, let me give you some kind of fundamental understanding here. So the security model can be broadly divided into two categories. One is called as fundamental security models. That means those kind of fundamental things should happen everywhere. And then there are high level models as well. So let's talk about the fundamental security models first. Number one is something called as state machine model. So state machine model simple says that everything what is happening on a computer system is actually a state. If your system is shut down, it's one state. If you restart it, it's second state. If you open a particular application, it's the third state, and so on. So every state has to transfer, like from one state to second state, the system has to go at any point in time. And when it do a transition from state 1 to state 2, it has to happen securely. It should not land the system in an insecure state. So that is the state machine model, fundamental models we are talking about. Then there is also something called as non-interference model, which says that do not interfere with some other processes. If a process is working something, it is doing some processing, let it do within its own boundaries. Do not disturb other. It's like, for example, you had a bad day or bad fight with your wife. You should not be disturbing your neighbors, right? Simple as that. So that is the non-interference model. And number 3 is called as information flow model, which says that information should always flow in accordance with the security policies of the system. So there are 3 fundamental models, and on top of that, we have high level models, and these high level models can also further be divided into 2 categories. What are those 2 categories? One is called as a lattice model. So when we talk about the lattice model, I think you guys can visualize a ladder. In a ladder, we have 2 pillars, and in that there are interconnections, right? That is how we climb. So one is a subject, another one is an object. Now, what is a subject? Any active entity. It can be you, it can be a process which actively working on something is called as a subject. And on the other side, on which you are working, or the process which is being called becomes as an object. It can be a file, it can be a process, anything. So there is subject and object, which becomes the two pillars of this lattice, and they are interconnected through some kind of interconnections, just like in a ladder. So that is nothing but the rules that defines how a particular subject is going to access an object. That is why we call it as a lattice model simple. And in that, there are certain models, for example, Bell-LaPadula model, Biba integrity model, right? All these kind of models, and Lipner model also, they comes under the lattice based kind of models. Now, on the other side, we have rule based models, which works on rules, simple as that. And in that, we might have Clark Wilson model, Breven Nash model. I think fundamentally you should be focusing more on these four models because they are more tested. Now, I'm a little bit coming on the Bell-LaPadula model. So Bell-LaPadula is a confidentiality model. You must understand that very, very clearly. It only addresses confidentiality. It also does not address covert communication. And there are three intrinsic, you can say, rules, which is no read up, no write down, and tranquility, property, which says that you cannot change the system properties when the system is working. Okay, so just understand that much is sufficient for you for exam purpose. On the other side, there is Biba integrity model, which is focusing more on the integrity of the system. Please understand, it's the integrity of the system. And to maintain this integrity, there are three security rules. We call it as axiom. And there are basically three such rules. Number one is called as no read down. You should not be reading data from any level which is below you, because let's say a manager is referring to all the time relying on data which is coming from the bottom, then the data may be having inaccuracies and that might hinder your decision making. That is what this rule or philosophy says. Okay. On the other side, there is also something called as no write up. And obviously, if I'm a manager, I should not be able to write a file for the director, like in under his access, which is a direct, loss of integrity by itself. So these are the two models. Basically, I can say the Biba is a inverted form of Bell-LaPadula. That is how it is. And can those both be implemented together? Answer is yes, they can very well be. And how do we do it is very, very simple. There is a model called as Lipner model, which addresses confidentiality and integrity both. Okay. So these are the lattice-based models. Now let's jump onto the other side, rule-based models. And when the rule comes in, the rules can be static. Rule can also be dynamic. When we say static rule, means static hard-coded rules cannot change. Every time the administrator has to go and change them. And dynamic is you write once and use it based on the context. So there are multiple rules which helps you for in multiple scenarios. In today's world, we are relying more on the dynamic based rule, but where security is heavily required, let's say in today's world, even in firewall, we go with rule based, direct rule based, static rule based. Now, let me talk about some rule based model. So first one is called as Clark Wilson model. It is again the integrity of a commercial software. For example, I will give you a very simple example to understand this. Let's say today you have to fly in from Dubai to San Francisco. Now, for doing that, what you need an aircraft, and for booking your flight, you need to go to a particular website and book it. When you go and book it, does the airline ask or allow you to directly go and write a data in their row? Because end of the data, your entire ticket is nothing but a single row in the database somewhere. Are they allowing you to do that? No, right? Because you might be interested. You are on internet. You might be interested. There are good people, bad people, always. We call it as UDI, untrusted data, element. And then this untrusted data information has to be converted into a trusted and something called as CDI, constraint data item, some data which is under all the constraint. Now to do this, they will never allow you to directly go to a database. They will give you a website. You need to go and log into that website. That website is nothing but called as transformation process. right? This transformation process will have a lot of checks and balances. Let's say your authentication and your own data input and all of it, that is called as integrity verification process. And once you do it, then only you can go and convert your UDI, untraced data item, into a constrained data item, and your things are accepted and you book a flight. So the whole purpose of Clark-Wilson model is to help you to maintain the entire integrity of the system from a commercial perspective. It is more of a commercial model. Then last one I will not even talk about Harrison-Russo model and all of it. That might be very, very confusing for all of you. Not too much required. Okay, just understand there are access code model. That is how access control models are defined. The next one is Brewer-Nash, and Brewer-Nash addresses conflict of interest. Let's say in a company you are here, you are into a consulting company and you are giving services to multiple firms, and let's say out of those multiple firms, some of them are competitors. Would you allow a single person to have access to both the competitors? Never, right? From a process perspective. But at the same time, how do we implement it on a system perspective as well, from an access control perspective? So that is where we use some dynamic rules. And because we are using dynamic rules, they can be applied based on the context. They can, they are very flexible in that particular case. And that is why we also call it as a Chinese wall model as well. Brewer-Nash, Chinese wall model. So that is what, that is how these models are. Okay. So basically there are fundamental rules and there are high-level rules. Fundamental means state machine model, information flow model, non-inference model, and then on top of it we have high-level models, which includes your Bell-LaPadula, Biba, Clark-Wilson, Brewer-Nash. You need to understand their goals, most important, and then if you understand one single two-liner about it, that is sufficient for the exam perspective. Now, also in this objective, we have something called as covert channels as well. So covert channel is hidden communication. Let's say you received an email, got trapped into a phishing thing, you clicked on a particular attachment, might be in the backend, there might be a system installed on your system, and that particular software, a malicious software, is trying to send a communication to the command and control center. So they don't use the normal way of communication, because for that you might already have rules in your security controls. They try to hide the way, or they have to take a different channel to communicate that information. And there are two channels in which they can do this. One is called as storage based covert channel, one is called as time based channel. When we say storage based, means store something, and when you store something, let's say it's talk about one, when you remove it, when you delete the file from a shared memory, nobody is stopping you from doing that, then it will be treated as zero. You write, you don't write, you write, you don't write. And when it is mixed with time, okay, you don't write for a certain period of time, then 0 and 0 will continue, and those kind of things. So that is how covert channel happens. So there's a little bit of introduction in this about the covert channel as well. Then finally, I know it's quite a lengthy one, because that is how this objective is. The last thing here is we are talking about certification and accreditation. So very clearly from the exam perspective, you need to understand what is the difference between certification and accreditation. Certification and accreditation is a very known thing across the industry. Let's say you are making a particular product and you want to sell it, then you will always go for some stamping from somewhere. And for that, you reach out to certain labs and all. That is where there will be a technical assessment of your product, not with the interconnected systems, only that particular product. And then they are going to say, okay, these are the criteria based on which we have tested you, and this is where you stand as per the criteria. Though having a evaluation criteria, having a particular rating does not mean that the product is secure, but that only shows on what level of testing has been done into that. So certification is more of a, you can say, technical assessment. And once the technical assessment is there, you are getting a rating, you are getting an analysis which talks about the level of risk which might be existing into the system, which will help the management to decide, should I go and implement this particular solution or shouldn't I do it? So accreditation is a management process, always focused on risk, and from where you get the estimation of the risk, that is from the certification. Certification can be external to the company as well. It can be internal to the company as well. Let's say you are going to acquire a product. That is where also we can go with that same thing. Okay. Now, when these particular third parties or labs, they are doing this entire evaluation, they have to do it based on certain grounds, right? Based on a baseline. That baseline is what is called as evaluation criteria. One very common evaluation criteria is something called as um, um, this one, ISO 15408, that is called as common criteria. Now, there are common criteria labs across the globe. You need to reach out to them. Your product which you are going to submit for evaluation, that will be called a target of evaluation. Now, when you go and give it to them, then also you have to prepare a documentation saying, okay, this was your requirement and that is how I have implemented. These are the artifacts. So that is called as security target, the documentation. And once you submit it, they are going to evaluate your product based on certain baseline. You have to download those baseline beforehand. That is called as protection profile. So protection profile will come from the particular certification lab. There's a common criteria website. Once you get certified, your name will be listed, product will be listed also there. So that is one thing. And once you get common criteria certified, you don't have to every time go and get evaluated, let's say even for a particular update. There is a security report, security impact report, which you are going to submit to them, and that is how the process actually works. So that is what this objective is. Very, very lengthy, I know, and it might have taken some time. Okay, fine, but guys, this much time you have to spend. There is no other way. Okay, so over to you, Pratima ma'am.
Oh my God, that was so huge. And how much to retain such a big knowledge? I
No,
think
no,
this is a
no, no, no. My
to
my
learn.
simple theory for the people is, do not go for memorization a lot. You should understand this as a story. You should,
Yeah,
that is a new knowledge to you as a leader, and you should understand how I'm going to approach in a given situation. Nobody is going to ask you what and why, which particular evaluation level, what happens, what are those specific security requirement, all of it. Nobody is going to ask you that. The thing is, as a leader, you should be knowing that this is the thing which is happening and how my product is fitting into the entire scheme of thing, what is what, and that's all. So just take it easy, that is what I would say.
that was really a big thing to retain. But okay, before moving forward, guys, we have this CISSP success toolkit with us, where there are around 650 plus success stories we have covered so far, and this is the 100 days of CISSP preparation plan, which you can enroll for this, and this is very functional CISSP success toolkit, 100 days of CISSP plan, where you get more than 60 plus hours of exam practice live sessions by the coach Manoj sir, and 30 plus hours of our doubt clearing sessions we have, and there are a lot many other features which you would love to explore. So if you feel like preparing yourself in a very strategic way with a proper mindset and framework, do reach me out. The number is already reflecting on the screen, and yes, then you are just a step away from your CISSP dream. So do reach me out, and there are a lot many other features included in CISSP success tool. So moving ahead now, let's talk about there is a huge series of it. Um, okay, now the next objective, which is about select control based upon system security requirements. Now, what is this, and how this is important from CISSP exam perspective? What type of questions the candidates can expect from this objective?
Okay,
Sir,
that's
so over
great.
to you.
That's, yeah, that's great, ma'am. So this by far, I would say, the easiest of the objective in the entire domain number three. This talks about select control based upon system security requirement. So the fundamental thing is, man, it's not copy paste. Security is not copy paste. In my domain number one also, When we spoken about the security program, we spoken about the same thing. It's not copy paste. So whenever you are designing the systems and architecturing and engineering the system, it's not copy paste. You have to go very specific as per the particular system. That is where you do threat modeling, risk assessment, all these kind of activities. And once you do all of it, you need to do something called as scoping. Okay, something called as scoping. For example, in ISMS we have a statement of applicability, right? That's nothing but an example of scoping. That is where you write down what controls I need to meet my regulatory, business and contractual requirement and all of it. It might be from a technical product perspective as well. Same thing, you have to do your scoping. Once you do the scoping, right, you might have to map your controls required to a particular framework. So this objective also talks about certain major frameworks which are available. For example, COBIT, which is focused on how do you are going to set the processes for your enterprise IT. You might have to talk about ITIL, which is IT infrastructure library, where you want your security or IT to be a service to the others in the company. That is where you can implement ITIL. Then we speak about NIST Special Publication 853, basically cybersecurity framework, NIST Cybersecurity Framework version 2.0, and for that we are going to pick up from NIST Special Publication 853. Then talks about PCI DSS. If your system will be handling credit card information, credit debit card information, all of it, you need to get compliant and take the controls from PCI DSS. You might also be like to visit ISO 27001 2022, and that is where there are 93 controls you can pick up from them. Then there is Sarbanes-Oxley Act, which is more focused on the financial record keeping and all of it. If you are working in let's say any part of the world and you want to work with the US government, then you need to get compliant with the FedRAMP. If you are providing your services from the cloud, your services are hosted on cloud. So as this objective, when it talks about the scoping, you are going to see which particular framework is applicable for you, and you can pick up these particular standard practices and controls from there, and then you can prepare your scoping. Once you do your scoping, it's not necessary you do exactly as it is stated into the framework. Your company requirement may differ. You might have to customize the control based on your requirement, and that is what is called as tailoring. So this entire objective number 3.3 is talking about the scoping and tailoring. Those particular control should be selected as per your system security requirement, and then they have to be applied based on your tailoring requirement. That's all. That's the bottom line of this particular objective. So that's it.
Okay, so it is not that difficult as though it seemed as if it's going to be very critical. But
Yeah, I told you,
okay,
right? Most simple one.
so maybe among so many difficult objectives, we got a little bit easier one. That was
Yeah.
objective number 3.3. All right, thank you for that. And let's move on ahead to the next one, which talks about understand security capabilities of information systems. So, what would you like to say about this?
Again, a big one, ma'am. Again, a big one. And I'm pretty sure so many of the people will feel like they are going back to their engineering days. But let me make it little interesting for you, right? So, system capabilities of the information system. You know, guys, we have a lot of information systems which are around, which actually takes in some information, they process it, and then they give back you the intelligence, right? So they take on data, process it, give you information. That is what we call it as information system. Now, most of the computing information systems, they are having some fundamental security architecture requirement, and that is how we can see in today's world the operating systems and the hardwares and all, computing hardware and all, they follow the same. So basically there is a concept, and it is basically coming from the Department of Defense, this term, right? It is called as trusted computing base. Now, what is actually trusted computing base is nothing but the combination of all the hardware, software, the core part of this hardware, software, firmware, middleware, all of it, which actually forms the most trusted base of your computing system. Okay. Now, this might look very theoretical to all the people, all our audience. So let me simply break it down. Okay. In an operating system, let's say you have a kernel, right? That kernel is nothing you can compare with TCP. As simple as that for the understanding perspective. So it is just a term which is you might not even heard into your engineering days, but that is there. Okay. Now, when we talk about this TCP, it's a combination of hardware, software, and firmware. Let's pick up them one by one. How do we maintain security of the hardware of a computing system? Now, to understand that, we need to first understand what are the components which comes under this hardware. So number one comes your CPU, and another one comes your memory. Let's pick up the CPU first. Now, how you make sure that a hardware, when processing the information, let's say your CPU, when processing the information, is not getting compromised. So we have to have some security mechanism for that, right? Now, that is very simple. The CPU actually operates in two modes. One is called as user mode. That is where it's like a doctor who is highly efficient, the most efficient guy as a this thing. There are a lot of patients who are sitting outside. Let's say they are called as processes. So every process is coming with a problem to get addressed by the CPU. That is how the patient will come to the doctor. And when the doctor is going to treat them, let's say a patient is infected by COVID. So he must have mask. The doctor also should have mask. So there is some protection mechanism, right? So in this case, when the user mode is being used in the CPU, that means where a low trusted process will come and talk to the CPU. When it talks to the CPU, it will work in a very limited privilege level. Okay, very few things the process can access. On the other hand, let's say this particular doctor want to talk to a very special patient, somebody who's part of the staff earlier, right? Then that particular guy he has higher level of trust, right? So he can come and talk directly to the CPU. That means it is more of the supervisory mode in the computer. That is where all the kernel level processes which are highly trusted, they can directly interact with the CPU. They have more access to the CPU commands and all of it. Okay. By the way, on the CPU, because CPU is a busy guy all the time, it is the most efficient guy, but the most busy also at the same time. So all the processes which are coming should not completely occupy the time of the CPU. So there is something called as a compounder, which will make sure there is an interrupt. There is an interrupt to it. So there is a method of time slicing which we use. Normally, it looks like a CPU is a multi-processing CPU, but no, there is no multitasking kind of concept. Even CPU process one command at a time. But the thing is, it works it based on the time slicing. This particular time slicing has to be initiated through a bell. That bell is called as interrupt. Some of the interrupt are low priority, like normal priority. Some of them are high priority. For example, if you have 10 processes opening on your system, you want to do a restart, the restart will take a highest precedence. For the doctor, if patients are coming, let's say 5 minutes each patient, then the bell will ring, the next process will come and all of it. Within these 5 minutes, if you have resolved the problem, it's good. Otherwise, the patient had to go and back come in the queue, right? But at the same time, let's say doctor wife itself has come. So that's a high privilege, right? That's a high privilege. He can't ignore it. It's a high priority interrupt. So he has to go out. There's no other go. So that is how the interrupts are actually working on the CPU. So that is how we secure the CPU. The next thing is, how do we secure the memory? So in memory also, there are two concepts which are there. Number one is isolation. Every process must work within its defined trust boundaries. Number one, आपको घर में जो करना है कर लीजिए, बाहर टेंशन नहीं देने का किसी को, right? So that is what is isolation. After the isolation, even in isolation also, there are very clever processes which are coming. Sometimes they may try to read the memory of the random access memory, because all of this process will come into the random access memory before getting to the doctor. So when this particular process is kind of sitting on the memory, he should not be having the actual address of the memory, because when the particular malicious process have the actual address of the memory, then he can jump at it will, and there can be very easily escalation of privilege can happen. That is normally what happens through the buffer overflow attack. So we need to prevent it. So how do we prevent it? Very, very simple. You don't tell the memory address to the process by itself. but the process will need it because somewhere it has to sit. So we give them some kind of relative address. We don't give them absolute address. Absolute is physical memory address. We don't give it to them. Only high trusted process will get access to that. For anything which is low trusted, we are going to give them relative address, or you can call them as virtual address. Now in that as well, sometimes attacker can leverage that also. So what we normally do, we actually go ahead and um, we say that a particular tell it. So what we do it is the entire address thing, the entire address layout itself, we are changing every free milliseconds. So that is called as ASLR, address space layout randomization, that helps to prevent attacks like buffer overflow and all. So I think that is what from a hardware perspective. Now coming down also on memory. In hardware we also have memory, like we spoken about RAM. Let's also talk about hardware, hard memory as well. So there is cache and all those kind of things also, and that is where we use sometimes encrypted drives and all of that to save the information. Then it comes to the software. When it comes to the software, every computing system, let's say an operating system, has a virtual concept in which every process will be given a particular level of trust. And on this trust level, you can see entire operating system can be into a ring-based architecture. The innermost ring 0 will have like kernel level process, which has the highest trust. As we go out, the level is less. The entire bottom line, the bottom story here is, when a process on a low trust level is going to give a call to a process of a high trust level, right? At that point in time, it has to be ensured that the authentication is happening at all times. The mediation must happen at all times. Okay, so that is very important to understand. So that is how we have the policy enforcement point. That means there are some component in the operating system which enforce a policy. That means every process must go through the authentication process, and there is a policy decision point. Now, when it comes to policy decision point, let me stress upon a little bit here. Let's say you have a kernel, which obviously we use spoken about as a TCP. In your kernel, we have a security kernel, which is responsible for making sure that it has all the security interfaces and kind of overall in charge of security. Inside security kernel, there is also something called as reference monitor. Reference monitor is a conceptual thing as a policy decision point. It is a particular process which is actually doing the authentication for the system. For example, in your Windows system, you have LSASS file, which takes care of authentication. So this particular reference monitor will make sure that all requests which are crossing the trust boundaries must be authenticated. And when they do this authentication, what if the reference monitor itself is getting compromised? It can happen, right? Possible. So we need to protect it. When we need to protect it, it's very simple. We have defined a certain way and a certain process through which a particular process can get authenticated by the reference monitor. Now, that trusted process is called as trust path. Okay, so that is how you can see this entire when it comes to the operating system. Now, when it comes to the third thing, that is the firmware. Now, what is the firmware? It's a combination of software and hardware. Okay, so it is a software inbuilt into a hardware. That is what we are saying, firmware. Now, when it comes to the firmware, it is very useful when it comes to the security part. Most of the firmware which are on security, let's say your TPM or HSM and all these kind of things, there is a concept called as silicon root of trust. That means they also detect any kind of tampering and they make sure that nobody is touching them like that. So they maintain each and everything, logging and everything. Now, this TPM is on a system level, whereas HSM is on a broad volume level, enterprise level. Okay, a system, let's say in your company, you want to implement disk encryption, right? And when you encrypt a drive, you store the password on the drive. Is that good? No, it's the worst thing. It's like sitting on the same tree and cutting it. So you cannot have the key on the same, this thing. You have to keep it separate from that. Where do you keep? then that is the best way to keep it on the motherboard. That is outside this equipment also, and you can do it. So that is where TPM will maintain your keys. TPM has two parts. One is called as your storage part, one is called as your processing part, integrated circuit. Storage is used for storing all the certificates, private keys, and there's a concept called as key encrypting key also, which is used. And it has some kind of enrollment key, which enrollment key is further helping you to derive your PKI related keys when you enroll a particular system into your domain and you want to connect with it, so that the device level authentication can also happen. For example, you want to implement network access controls. That is where your TPM will have that certificate to get your device level authentication done to your network, and then your system will get the IP address, right? So your TPM is helping you to secure all these keys very, very securely. And one more important thing, it can also store cryptographic hashes. So when you switch on a particular system, it will detect if there is some tampering to the firmware of the entire motherboard by itself. That is called a secure boot. So, or we can call it as initial state as well. So that is where your TPM is very, very helpful. So that is the way to think about this particular objective 3.4. I know, little technical, but I think without slides, I have done a fair job, I believe, to explain all this. So over to you, ma'am.
Thank you so much. And guys, are you still alive? Hello, is everyone there? If you people are still alive, then just
Ma'am, it's very
yes.
interesting. There is nothing to feel like alive or not, because that
No,
is how you
it's
have to go through this churn to get your CISSP, guys. There is no second thought.
yeah. No, but thank you so much. This is how you have explained these tricky concepts in with such an ease, and thank you. So let's moving ahead to the last objective of today's session. Though there are many various left out, we'll covering in the next sessions, coming up sessions. So the fifth, the 3.5 objective, it speaks about the access and mitigate the vulnerabilities of security architectures, designs, and solution elements. A huge list of sub objectives are also there on a screen. So, sir, please throw some light on these objectives too.
Okay, guys. So again, you have to bear with me for another 10 minutes, maybe. And that's very, very interesting. And I am telling you guys, very important from the exam perspective. Many people get pissed off from this particular objective, but that's how it is. Very, very huge. But I will try to make it more interesting and keep it little focused as well at the same time. So, you know, we are using a lot of systems, information systems. It can be IoT, it can be computing systems, it can also be HSMs, and those, like, so many things, right? We are using on a daily basis, even to the ICS and the SCADAs and all of it. Now, all these systems, there are some common vulnerabilities. For example, one of the common vulnerabilities is single point of failure. We don't have redundancy, right? Then some of them might allow bypassing of the controls, some other way to bypass the particular control. That is also there. In some of the system, when it comes to access to a particular process, there is something called as race condition. Race condition is where the order of activities is not proper. For example, just think about if authorization happens before authentication. Race condition, right? On the other side, there is also one more thing called a talk to. Time of check versus time of use. For example, today, you are going to go to airport to pick up your mom, right? And airport is, let's say, 1 hour distance from your home. And you see, is there petrol in my car in the first place? Let's say there was 3 liters of petrol in your car. That's good. And you checked it. And then you went for a sleep. Your friend came in when you were sleeping and he started using the car. He went to the market and come back. When you go and really want to go and check out for your, go to the airport, that time you see the petrol is not sufficient. It's just 300 ml in that. That's a process, right? That's a problem. So in the system also, we are using a lot of shared memory spaces, and multiple process use the same memory spaces. If at the time of check, right, there's a gap between time of check and time of use, that can be misutilized by another process. That is what called as talk to. and that can be harmful for security as well as for stability of the system. And that is where we have to make sure that there has to be minimum gap between time of check and time of use. That's the way. Okay. Then another interesting thing, and might look like Hollywood kind of thing, is emanations. Can you believe a particular computer is running and I have a probe? I'm not even touching the system. On the remotely itself, there's some electromagnetic interference which is traveling around the system. I am having a probe. I just locate it, situate it near to the system, and on a remote system, I am trying to see what you are doing in your computer. Possible? Very much yes. It is possible, or that is called as emanations. So to prevent it, what can be done? We use something called as shielding. We can call it as tempest. We can also use white noise, which will be just confusing the user with the same noise in the same frequency, unmeaningful noise. And we can also use control zones as well for that. So these are some common vulnerabilities, and we must make sure that the system is hardened, not unnecessary ports and services. You have antivirus software, full disk encryption, password policies, and big thing, right? Now, this objective also talks about some more individual information system, let's say mobile systems. So mobile system can be vulnerable because you may allow people to access your email and other things on the mobile, and this can be very tricky. So because you might allow some more permissions to some of the apps on your system, and they can access your corporate data. Then how corporate data is secure? So we use something called as MDM solution, mobile device management solutions, and that is where you can enforce the policies. And when we enforce within MDM, there is a component called as MAM, mobile application management, that will create a kind of balloon around your secure corporate applications. So any application which is trying to access those applications must go through authentication, not allowed, all these kind of things. That is where you can see even on normal mobile also nowadays, we have Google Pay and Paytm kind of applications, payment applications, and they are not getting compromised, right? Because we have this. Okay, so that is how you can see this. Then when we talk about websites and all of it, they're very common vulnerabilities like cross-site scripting. Attacker try to get access to your, I think better we talk about in domain 8, otherwise the session will become very huge, right? So cross-site scripting, then cross-site request forgery, all these kind of things are very common. SQL injections are very common across the system. And you need to have appropriate controls, like input validation must be very good, parameterized queries should be very good, your cookie setting should be good, your content security policy must be there. Those kind of controls, I think more we will stress in domain number 8. Then there is also ICS systems as well, industrial control system, and they may have DCS, they may have PLC, and they may have SCADA as well, and all that also need to be secured. One of the challenge in this area is that all the ICS systems are very costly, and nobody will go and purchase it for next 10 years. I'm going to purchase it for next 100 years. And in today's world, every second year the technology is changing, and every third year they may become outdated as well. So often all these ICS system, they become legacy. Now, when they become legacy, the problem is if my production environment is connected with my legacy system, then very easily the attacker can enter from the ICS system into my production system, right? And because ICS system is operating, machines are operating with humans, that itself must be protected. And that is where we use controls. For example, proper segregation. We make sure the traffic which is coming outside is also very much controlled. So we use something called as data diode, which helps to data to be traveling only in one. Data can only come inside, it cannot go outside. So those kind of controls you have to think. Also, if you are managing your ICS system, let's say through a management interface which is remotely located, then bring that ICS system also and the management interface also in the same network and try to isolate from rest of them. So those are kind of things which this talks about. Then next type of information system is talked about is IoT. And IoT means small devices, very little memory. It can be your IP camera, it can be your printer, it can be your coffee machine, and so much of that. Can they be vulnerable to attacks? Very much they can be. And that is the prime attack. That is how Mirai attack has happened, right, in the past. The thing is, they can be very easily compromised, and they are manufactured in bulk. If the attacker is able to identify one flaw in one model, he can target lakhs of companies altogether, right? That's a huge vulnerability when it comes to IoT, and barely I see any company ever focus on updating or patching the IoT devices. Nobody does. And that's a big area for attackers to go and do that. Then there are database systems. Database systems are critical, and that is where inference and aggregation can happen. So what is aggregation is, as an individual, you go to Flipkart, you go to Amazon, you go to some different website, Facebook, Twitter, all of it. And these are different databases. By itself, they may not reveal something very important for you. But the attacker has the ability now to collect this information from all these databases, and that is called as aggregation. What he's trying to do is inference. That means from the non-sensitive data, he's trying to infer something which is very sensitive. That is called as inference. Okay, so that is there. And then there are cloud systems as well. We go with infrastructure as a service, or we go with platform as a service, and these kind of stuff. I think we'll talk about that more in domain 8, maybe on cloud will make sense. Otherwise, this particular objective is huge. On the other side, we are also using high performance computing nowadays. That means it's a distributed architecture. For example, supercomputer. Supercomputer is nothing but an example of high performance computing by itself. And supercomputer is supercomputer because there is a central node, and then the processing is happening on different nodes. Each and every node is processing the data and then giving back to the central nodes, right? And there is direct memory access also between them. Now, in these kind of system, if there is a async between them, the synchronization is not well, or a particular system is compromised, then the entire system may get compromised. Those are the kind of vulnerability from a HPC perspective. So likewise, there are a lot of, you can say, vulnerabilities in these kind of systems. IoTs we have discussed. The distributed system. Guys, what is a distributed system? A distributed system is a system where, there is a central application or system, and then some of the processing is happening on other system. For example, very easy to relate. I have given you an example of, let's say, some website. You are going to book the ticket. Now, when you go to that particular website, let's say Make My Trip, you are trying to book a flight. You just tell it where I want to go, this and that, and then you click on submit. Is all the processing happening on Make My Trip? Is Make My Trip owning all the airlines so that it can give you pricing and everything? No, right? This is an application architecture in such a way it will make the entire query as an object, JSON object. This JSON object in an API request will go to different servers where it will get processed. That means you are trying to request, okay, this is the date, this is the number of passenger, this and that, please give me the price. So some processing happening on the remote system, and then this will give back to the system. This is a very good example of distributed computing. We are living in a world of distributed computing by itself. Even right now, the webinar we are doing here, this particular podcast, madam is on a different system, I am on a different system, and you are on a different system. So this is all distributed computing, man. In a distributed computing, let's say right now, what if your videos go down, or there's a low bandwidth, or there's a network problem at your end? So something will break down, right? That is one of the challenge when it comes to the distributing computers. Right, more on that I think we'll discuss more in domain 8. So I think that is how I would like to conclude this objective 3.5. Take it with the you can say interest perspective, guys. You should know what are the common vulnerabilities related to the major information system, all of it. I hope, guys, you have enjoyed. I know this particular domain is very huge, very huge. I have tried to be as short and crisp as I can in my main classes. I tear this entire topic and you become a master in that. And we do a lot of practice also, just going through the concepts. I'm telling you all these objectives in this entire series of podcast. We are trying to give you the right mindset for it. But believe me, until you go and practice, the things are not going to happen. So if you want to practice live with me, in the sessions, in the live sessions, then join the CST program. It's a wonderful program which has everything you need. No books, guys. Number one, You don't need to go through any heavyweight book to pass the CISSP. We have smart notes. There is a book which has been written by me. It is part of the program by itself. Then there are inbuilt 4,000 questions for practice. There are inbuilt videos, there are punch statements, there are daily practice questions, and so on. And more on that, there is a one-to-one mentoring also. So that is what. So I think next section we will go with the domain number 3.6 to domain number objective
I
number
mean,
3.6 and
yes.
3.7, not even 3.8. I want to take physical security separately. So we'll go with
Okay.
3.6 and 3.7. And that will be very, very interesting, guys. We will talk about cryptography. We will hear about cryptography entire thing. Very, very important session also coming up. So, yeah, I hope you all enjoyed. And back to you, Pratimana.
Yeah, thank you. Thank you so much, Manoj sir. I hope the audience would have gained some insight with your, I mean, they have gained some value out of this session. And thank you all. And let's meet next week, same timing. We'll be live discussing about domain objectives, which is domain number 3. We'll be discussing about 3.6 and
3.5, 3.6 and 3.7, basically. Yeah.
till 3.8. So thank you so much. And your comments are most welcome. Please comment below and do share your thoughts about today's session. And we would love to meet you again next week and come up with these remaining objectives with you to discuss about. And special thanks to the our speaker Manoj sir for his
Yeah. And
insights and
guys,
guidance.
if you're really enjoying these sessions that is helping you into your mindset and everything, please do comment. Let us know how much you are loving us.
Yes, that's true. That's true. And thank you. And let's meet next week then. And see you, all of you. Thank you for joining the call. Thank you.